And Ross?
My name is Firefighter Max, and I've been in the fire service 19 years. I'm here tonight to teach y'all about fire hoses, water hammers, and we're going to go over cleaning and draining a fire hose and carrying a fire hose. We'll start with the construction of the fire hose. Most hoses are constructed with an inner waterproof liner surrounded by 1 to 2 outer layers. NFPA 1921, it sets the standards for what the lengths or diameters of the hoses are. And I'll start with this here. Got an 1.5-inch fire hose here. These are drop forged couplings, and you have an inner rubber waterproof liner, and then the outer layer is made of woven synthetic nylon. You have the top layer provides the protection for abrasions, hot embers. The second layer is what gives this fire hose strength. The couplings have a male and then a female coupling. I'll bring this around that y'all feel the stability of the hose. You feel the thickness of it and see the diameter. The inner layer provides the strength, it holds it together. The outer layer keeps it from, like I said, hot embers, high temperatures, mildew, and chemicals. Some hoses are double jacketed, and that's where the 2 layers come from. The outer layer for protection, the inner layer for strength. NFPA 1963 tells us what the design for the couplings. They can be cast, extruding, or the drop forge. In this case, this here's the drop forge couplings. You have on attack lines, they're tested to 300 annually to 300 psi. They are designed to go up to 275 psi. Your supply lines are tested annually at 200, and they are designed to withstand up to 185. So these are tested annually for leaks or failure. You don't want to get out on a fire scene and have one fail on you. But there's other different types of constructed hoses. There's some rubber collapsible hoses. You'll see that on your field lines, supply lines. You can actually, with being collapsible, they're more called soft suction hoses. Then you have a solid rubber hose. You'll find them on hose reels, booster lines, trash lines. They're on a reel somewhere on the pumper, depending on your department's need for them and location that they want the hose reel put. NFPA 1901 tells us the length the hoses have to be. Your soft suction are usually 15 foot, minimum 15 foot. Same as hard suction, soft suction. Your attack lines and field lines, supply lines, they're usually 50 feet section to 100 foot section. But NFPA 1901 tells us a standard on that. Your hard suction hoses are used for drafting out of a tank, or a dump tank, or out of a pond or a swimming pool. Now we're going to go over the different diameters. You have what we call a SDH hose, small diameter hose. They're usually your 1 inch to 2 inch. They're used for fire attack, and they're usually interior fire attack. They're usually 50-foot sections. Your inch falls into small diameter, and those, like I said, those are your trash lines. Booster lines are used for exterior firefighting, not interior. Most departments have a 2.5 inch pre-connect used for heavy fire, knockdown, quick attack. Most departments have a 2 inch and a half pre-connects. Those are used for interior firefighting. They usually have, those are usually 200-foot sections apiece. You have, most departments carry a 1 inch or 2.5 inch and a half pre-connect on the rear of the truck. That's usually about 350 foot of that in that pre-connect. Used for, again, interior firefighting. Your inch hoses are rated at 40 to 50 gallons per minute. Your inch and a half is 60 to 125 gallons per minute. Your inch and 3/4 is from 120 to 180 gallons per minute. And those, again, are all your small diameter attack lines. The next is your MDH, which is your medium diameter hose. That's 2.5 to 3 inch in diameter. Again, those could be used as attack lines or supply lines. And most of your fire departments use 2.5 inch diameter hoses for a quick attack. They usually on the rear of the truck on one side, usually the passenger side. They have 250 to 300, maybe 350, and it's used for quick attack on a heavy fire. So you get to, you pull up on scene, you have a fully involved house, through the roof, coming out every window, front door, in the front of the house. 2.5 would be a quick knockdown. You got more volume of water coming to that fire than 1.5 inches or 1 3/4. So you can knock that fire down for your firefighters to take the small diameter, the 1.5 inches, 1 3/4 to make an interior attack. Two and a half pre-connect is usually rated at 250 gallons per minute. Most departments, like I said, have a 300 foot of pre-connect. 2.5 tube is used as a field line. Most rural departments, they have about 1,000 foot of 2.5 inch supply line laid on the truck. Distance between hydrants may vary, so you may have a long way to go to a hydrant. They also at the time shuttle water in too, so you have the shuttling water drafting and coming off a hydrant. The next one we'll talk about is LDH, large diameter hoses. Most of those are 3.5 to 6 inch diameter. Standard in most departments is 4 inch to 5 inch, and they're in 50 foot to 100 foot sections. The 4.5 to 5, or 4 to 5 inch, those are primarily in bigger cities. They use that as a supply line, especially when they have to set up an aerial or a platform. They want the more volume of water coming to the apparatus. Usually those 4 to 5 inch, they have different couplings than what we've seen on the 1.5 inch or 1 3/4, or even the 2.5. They have Storks connectors. It's basically where the couplings come together. They have like a male and female. They interlock and then twist in place and lock. Totally different than spinning it on like these do. These here have the threads that actually you have to screw on the other coupling. These on these large diameter. You see in the picture here, That's what a Stork's connection looks like. It's just basically male, female together. They interlock, twist, and lock. And you can't pull it apart. Like I said, most major cities, bigger cities like Memphis, Nashville, they use the 5-inch or 4-inch because it's more volume of water coming to them than a 2.5. Us out here in this rural area, most of us use 2.5-inch field line or supply line. And larger diameter hoses, again, they supply more volume of water for long distance. So that 2.5, by the time you hook to a hydrant and you're gonna supply your engine, the further you are, the less water is gonna get to you. If you've got a bigger hose, more water's coming, so you won't have to worry about water supply. We're gonna talk about one thing that does damage hoses, and it's called water hammer. Water hammer is a fast-moving stream of water that has kinetic energy in it, and that sudden stop of water turns that kinetic energy into increased pressure. When that increased pressure happens, it instantly sends a shock wave back through the hose. When it does that, you can have couplings break, split open. You can have hoses rupture. If it gets its way back to your internal pump in the engine, you got pump problems. It can also damage the underground plumbing in the hydrant. And you can also cause a water hammer by opening the valve to your pump to charge a line. You can damage your pump that way by water hammer damaging your hose. So when you're on the end of hose, you want to shut that nozzle down easy and open it easy. But the same thing, the pump operator needs to open that valve easy and close that valve easy, or you're going to cause a water hammer that can do some serious damage.